Greetings, ladies and gentlemen. Thank you for joining me. Welcome to TJ's Maths and Further Maths Adventures. If you're coming across this channel for the first time, thank you for joining me. The returning viewers, I really appreciate you for your coming. Let's look at how we can solve this question before us. This is NECO 2024 and this is further mathematics. This is with us here is question 9a and 9b from the optional parts. This question 9 has got A, B, and C. I decided to put only A and B on the board because the question is very long. Let's look at how we can solve A and B. Then in my next video, I will solve C. That's 9C. Come with me as we solve this together. Question 9a and b reads: 9a, write down the binomial expansion of bracket open 1 plus half of x close the bracket power 5 and simplify all the terms. We are asked to write down the binomial expansion of this. Then we should simplify all the terms. B, use the expansion in A. We are to use our expansion in this A to evaluate 1.0040 power 5 correct to 5 significant figures. First thing to do is to identify this question is from which topic. Of course, this is from binomial expansion. And to expand this, we can either use Pascal triangle or we use the general formula of binomial expansion to expand this. There are two ways we can approach this, either Pascal triangle or the theorem itself. We can deduce the theory and use the formula. So let's use the formula here. Okay, let's write down the solution. We write down the solution now. The general formula for binomial expansion is given as n combination r times a power n minus r, then b power r. So this is the general formula of binomial expansion, given that a and b are the two terms involved. Okay, this our n here is the power here. Okay, since we are having power 5, it means our n is 5. We need to get all this information. Our r, the number of terms when you expand this has to be n more than 1. That's n plus 1. It will be always be n plus 1, meaning when we expand this, we have 6 terms. So it means our r will be 0, 1, 2, up to what? Up to 5. Then our a is the first term in the bracket, which is 1. Then our b is the second term, which is half of what? Half of x. Okay? Let's look at how we can expand now using this formula. It means when r is 0, we substitute, given that n is 5. When r is 1, when r is 2, when r is 3, 4, 5, in that order. So when r is 0, let's substitute into this formula. Now in place of this n, we'll have 5 combination 0 now. R now is 0 times our a, which is 1, times 5 minus 0. Then our b is half of x power r, which is 0. This will be the first expansion now. Plus, let's pick the next one. That's when r is 1. That will be 5 combination 1 times 1 power 5 minus 1 times half of x power 1. Next, when r is 2, that will be 5 combination 2 into 1 power 5 minus 2, then half of x power 2. Next, when r is 3, it will be 5 combination 3, 1 power 5 minus 3, half of x power 3. Next, when r is 4, until we reach 5, that's when we stop. When r is 4, that will be 5 combination 4, multiply by 1 power 5 minus 4, half of x power 4. Let me write down the last one now. Plus, when r is 5, it will be 5 combination 5, 1 power 5 minus 5, half of x power 5. So this will be the expansion now. Okay, the next thing is for us to use our calculator to resolve each term, then work on it. Let's move here. Since we need enough space, we need to move here to achieve that. Okay, first expansion here, 5 combination 0, 5 combination 0. Let's look at how we can do that. 5 combination 0, uh, 5 combination uh, 0 to be 1. So the whole of this will be 1. 5 power 0 is 1. 1 times 1 is 1. This one too is 1 because anything raised power 0 is 1. So this first, when r is 0, our expansion will be 1 plus. We move. When r is 1, it will be 5 combination 1. 5 combination 1 is 1. This first one is 1. Then 5 minus 1 is 4. 1 power 4 is still 1. So 1 times 5 is 5. Then we have 5 times 1 divided by 2 times x. That will be 5 divided by 2 times x. That will be the second expansion. Let's move to the third one now. When r is 2. So 5 combination 2 is 10. 5 combination 2 is 10. 1 power 5 minus 2 is 3. 1 power 3 is still 1 times 10, which is 10. But here we have half square. Half square will be 1 over 4 x squared, because this half square is 1 over 4, then x squared times 10. So we have plus 10 now times 1 over 4x squared. This will be our second expansion, third expansion, plus when r is 3, it will be 5 combination 3, which is still 10. We have 10 here. Then it will now be 10 times 5 minus 3 is 2, 1 power 2 is still 1. Then 1 cube is 1, 2 cube is 8. That will be 1 over 8, 1 over 8x cubed. This will be our fourth expansion, plus when r is 4, that will be 5 combination 4 is 5. Then 5 minus 4 is 1, 1 power 1 is still 1, 1 power 4 is 1, 2 power 4 is 16. That will be 5 times 1 over 16 x power 4. Okay? The last but not the least, when r is 5, that will be 5 combination 5, of course, is 1. The whole of this will give us 1 because 5 minus 5 is 0. Anything raised power 0 is 1. 1 power 0 is 1. 1 times 1 is 1. So the last expansion will be 1 divided by 2 power 5 is 32. Then x power 5. Okay? Uh, let me remove this. But before I do that, let me write down what we are asked to expand. The B part, let me write, we are asked to expand this using what we have up. Let me write it here because I need to clean that. Correct to 5 SF, 5 significant figure. Let me bring the B down here. Okay, so the next thing to do is to simplify this. So I'll have 1 plus 5 divided by 2 times x plus 2 here, 2, 2 here, 5. That will be 5 divided by 2x squared plus 2 here, 4, 2 here, 5. That will be 5 divided by 4x power 3 plus 5 times, that will be 5 divided by 16x power 4 plus 1 divided by 32x power 5. So this will be the simplification. This will be the solution to A. Okay, because we are asked to write down and simplify all the terms. Okay, so this is the solution to A. Let's look at how we can work on this B. Remember, what was given to us is let me write it here. The binomial expansion that was given to us for us to expand, uh, it was uh, it was 1 plus half of x power 5. We're solving a solution to B now. So we have to relate these two information. Okay, we have 1. Okay, so we can write this as 1.0040. We can write it as 1 plus 0.0040 power 5. So we have to relate this 1 to 1, half of x to 0.0040, then 5 to 5. So the aim now is to find x in this case. So it means half of x is equals to 0.0040. So let's cross multiply to find x now. X now will be 0.0040 times 2. Okay, that will be 2 times 0.0040. We'll have x as 0.008. So this will be the value of x. What are we supposed to do with this x? We have to use this our expansion here to substitute. Anywhere we see x, we put 0.008. So let's do the expansion here. Let's start. We're solving B now. So let's substitute x as 0.008. Okay, first we have 1 plus 5 into 0.08. Next one will be plus 5 divided by 2 into 0.008 power 2 plus 5 divided by 4 into 0.08 power 3. Next plus 5 divided by 16 into 0.008 power 4 plus 1 divided by 32 into 0.008 power 5. Okay, so let's look at what we have at the end of the day. We have 1 plus, uh, let's multiply 5 times 0.008. What do we have? 0.04 divided by 2. We have 0.02 plus next one, 0.008 square multiplied by 5 times 5 divided by 2 divided by, let's do it again, 0.008 square. Okay, multiplied by 5, then divided by 2, we'll have 0.00016. Okay, next, we're here now, we have 0.008 power 3 multiplied by 5 times 5 divided by 4. Plus 0.00000012345 6, then 6 4. Okay, plus second to the last now, when r is 4, that will be 0.08 power 4 times 5 divided by 16. We'll have 0.00001234567 then 128 123456789. That's power 9. Yes, so the last but not the least now, uh the last but not the least, let me take this last one up so that we can see it clearly. Okay, let's take it here before we add, plus 0.008 That's 3, 4, 5, 6, 7, 8. 1, 2, 8. Plus the last one now, power 5, when R is 5. Okay? So that will be 0.08 power 5 divided by 32. We'll have about 12 zeros. Okay, so 0.0000, that is 4, 5, 6, 7, 8, 9, 10, 11, 1, 0, 2, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then 12. Okay, so the next thing to do now is to add. Let's see how we can sum the whole of this together. Okay, we'll start from 1. 1 plus 0.02 plus plus 0.000, that's 30164, plus 0.01234567, that's 2345678, then 128, plus the last one now, 0.01234567891011, then 1024. Okay, let's count to have 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6. We're supposed to have 6. Let's check. Let's go back and check. This is for 1, this is for this second one, the third one, and the fourth one. Okay, let's check. 1, 1. Let's start from 0.00. Supposed to be 00 here. 8 times 5 divided by 2, which is this one. We move here. Let me still cross check. 0.08 square times 5 divided by 2. We have this one. Okay, next, when R is 3, 0.08 power 3 times 5, then divided by 4. Okay, we're supposed to have that's this. For this, we're supposed to have 0, 7, 0, 0. That's 0, 0, 0, 0, 0, 0. That's 6, 4. Okay, then when R is 4, which is this, when R is 5. Okay, so we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 now. Okay, so we can sum now. 1 plus 0.02, then plus 0.00016, plus 0. We have about 60. Okay, 4, 5, 6, then 6, 4, plus we have about 8 zeros here, plus 0.000, that's 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 8. Then plus the last one, 0.01234567891011, then 1024. At the end of the day, we'll have the final answer will be 1.02016 to 5 significant figure. 1, 1, 2, 3, 4, 5. That will be 1.0202 to 5 significant figures. So this will be the solution to this B. Thank you for watching. Please do share this to your learning colleagues, and don't forget to hit the notification button. Thank you for watching.